the plans for implementing with 3 industry representatives who have to make the job. And naturally, that's very important. And finally, Jean Blouvac from CNES, CNES, our host here, will offer and propose some tentative conclusions for the continuation of this debate. So I'm pleased with that to stop talking, actually, and to thank and introduce Bernard Foin, my friend, who will moderate this session. So thank you very much, Bernard, for being with us.
Thank you, Michel. So I think that we have been working with Michel on a number of topics that includes looking at our future, even to Horizon 2061, and actually we just released the book. And into this one, we address all targets in the solar system, but the closest neighbor, our suburbs of our nearest continent, is the moon, and clearly we want to protect it. So I'm Bernard Foin. I've been working like 30 years at ESA. I left ESA, now I'm trying to go to new adventures, in particular to promote the civilian space development, but also have the young professional joining us to prepare their future. And our future would be together, in particular on the moon. So I'm also working at COSPAR. As you know, at COSPAR we have a planetary protection panel, but we look also at the environmental aspect. So let's go to the next. Even 25 years ago, we put a roadmap for the exploration and utilization of the moon. And so we discussed that with space agencies, scientists, engineers, but also academia, also with industry, with explorers. And we wanted to engage society because clearly we have to be the caretakers of this 8th continent. So we discussed phased approach for the exploration and utilization of the moon. We call that the Moon Village Roadmap. And so we start with some orbiters that discover the new phase of the moon. We are going now through the phase which is a Lunar Robotic Village, which is done by many actors, international and commercial. And since 2013, we had a permanent robotic presence on the moon. But now we are engaging in the next phase where we'll have humans that will go on various outposts in the various programs. So we have the Artemis program, but we have also International Lunar Research Station program. And also we see some development of commercial ventures on the moon. So in the moment, we are going to prepare some large-scale facilities that will sustain human, but also there will be some production activity, manufacturing, we'll have food, and then we are looking towards 2030 to have a sustainable humanity on the surface of the moon. Humanity represented by a few, but this will scale up, and we could project that within 20 years we could have 100 or 1,000 people living on the moon. I plan to be one of them, actually, to retire there and to organize a campfire on the moon. But we have really to do that sustainably with responsibility because we are borrowing the moon to the next generation, and actually not only humans, we have also to preserve the interest of our whole biosphere. So let's see, okay, that's sustainable presence on the moon. So we have some vision. This is a near-term vision for in the 2030, 35 time frame, what we could have. And then we look also at next at multiple clicks, the various challenges of getting there, communicating, operating in this extreme environment, also survival, mobility with astronauts, and rovers. We will have a partnership between human and robot. In fact, there will be a few humans there, but there will be a large number of rovers that will be teleoperated from Earth. And of course, those, we have to look at the environment impact of all this operation. We want to exploit resources, so we have found water ice at the pole, but there are also silicate we can use for construction. We can extract rare earth elements. We could also even extract helium-3 from the surface of the moon. And you know, with 10 tons of helium-3, you could provide Europe with energy for 1 year. But you have to excavate a lot to do that. So we have to do that responsibly, find some technique and approaches to protect these resources. And last one is something that we don't do only for scientists, engineers, or government from taxpayers' money, but we want to involve all the community of users. So you are all citizens of Earth. You need to say your word. Actually, 30 years ago, this was my first IAC. I organized my first symposium on astronomy and space science from the moon. And then we had all discussion already on protecting the lunar environment. It was triggered by Professor Bonnet. He was at that time. And then actually we approved at COSPAR a recommendation of a very careful approach to protect the moon from the scientific point of view, the asset of the moon, but also as a resources and as a place for the future, to reserve some areas for science, MIT, others for exploration. So I recommend you to look at this highlight, at this COSPAR. In the meantime, we have done many missions, and we are at the verge to accelerate our expansion of our humanity to the moon. So let's see how we can prepare it responsibly to provide science, technologies, economical opportunities, also peace platform, and as well an opportunity for education, inspiration, what we call a space renaissance for all. So thanks for this introduction. So let's go to the next speaker now. David Korsmeyer, so he's a Deputy Director of the NASA Ames Research Center.
Thank you, Bernard. So I'd like to talk a little bit about what's going on within NASA and the practices we're beginning to consider as we start our actual formal re-engagement of exploration on the moon. And we've been promoting a number of different activities. One, the commercial launch payload services activity, which is instigating industry to provide the rides back to the moon. Now, as we get there, we're going to have to deal with a lot of different things. And next slide, how do I change the slide? Do I just, there we go. So the moon is a little bit new, at least for me, when I grew up. The moon was a desiccated, bone-dry, uninhabitable place. It was a desert. We went, we played golf, and we left. And there was no consideration of, except, you know, maybe helium-3 mining or something, that of resources of value being in significant abundance on the moon. Well, fast forward many years now, and we have rediscovered through numerous missions in the late 90s, starting in the late 90s and moving into the this new millennium here. L-Cross alone, which was another mission done at NASA Ames, was an impactor into Cabeza crater on the south pole of the moon. And by doing that, we discovered that not only is there valuable material, but there is water in abundance in the craters on the south pole and probably the north pole of the moon. We've been able to use that as our first touch, a little bit aggressive, mind you, but it was a first touch back onto the surface of the moon. And then we've subsequently flown several missions, LRO still being up there, mapping the moon. And we've discovered, along with many other countries, that there's great abundance of hydrogen. And where there's hydrogen, there's going to be water. And what we know right now is that we have readings. So we get the image in the lower left up of the screen. There's abundance, but we don't know how and where exactly, and how deep or how locked the actual hydrogen is into the materials of the surface of the moon, because you can't tell that through remote sensing. So we do need to actually go and touch. Next slide, please. Enter Artemis. So we've known this. We're trying to think about what to do. We finally, the U.S. and all the international member states that we can find, we're trying to sign the Artemis Accords, which is a planned program of the world going back and engaging in exploration, specifically starting at the moon and then moving onwards. And of NASA's first Artemis activities, the circled in yellow on the bottom there is this Volatiles Investigation Polar Explorer Rover, VIPER. A little bit of a strange acronym, but what it's going to do is be sent on this commercial lunar payload services, the first major mission that NASA is doing to the South Pole of the Moon, to the Nebulous A region of the South Pole, and it's going to drive around very fast and has a drill that will go down a meter and has measurement systems. Well, next slide, I'll show you. Measurement systems specifically designed to look for and validate where and how the water is entrapped in the moon. So that's the VIPER rover on the side. If I was to stand in front of it, and I've stood in front of the engineering development unit, my head goes up to where the lights are. It's relatively large, and I'm 180 centimeters. So it's a large rover. And what we're going to do is, you can see the image to your right, that's a false color image of the density of the hydrogen on a permanently shadowed crater in the moon. So the yellow is kind of light, then it shades a little bit to this kind of strange green, and then red is where we know there's significant hydrogen, but we don't know how it's entrapped. So we're going to drive into the permanently shadowed craters. We're going to drill in, pull up the material, and see how deep is it. Because it could be anywhere from just entrapped in small ice crystals on the surface uniformly down to a few centimeters, or it could be blocks of ice. It could be icebergs literally sitting there, or any variation in between. And so from that, we're going to effectively prospect. We will validate what the remote sensing signal says against what the ground truth is, and by doing that over a significant region, a couple square kilometers, tens of square kilometers on the lunar surface over a 2 lunar day mission, we will be able to then correlate that with global imaging of the moon, and we will get a mineral map. We will get a resource map of where ice is, and probably how it is entrapped from the signatures that we are able to correlate between our remote sensing and the ground truth we're going to do with the VIPER rover. So we will all of a sudden have a treasure map. What do we do with that treasure map? What do we do? We're a government agency. We're going to do good science on it, but what do other people want to do with it? That's the question. Next slide, please. One of the things we're going to look at it for is it will potentially give us an idea of where resources, NASA and other states doing the Artemis and other exploration programs could find resources, in particular water, which is the new gold, so to speak, because it will allow us to either breathe, drink, and or burn in one fashion or another for energy and for fuel that we don't have to bring up from Earth. And so knowing that will instigate a desire to make use of it. So we'll work to establish engineering technology test beds that you can use it, and then what? And that's where I hand off.
Excellent. Thank you, David. So we are going there. We are going forward to the moon. We are going to do science, discover new things, explore these resources, look at techniques to use these resources, and prepare for humans. So how are we going to use some of these resources? For this, we are going to listen to Barbara Himov. She's a space architect, and she's also CEO of Liquifer System Groups in Vienna. And she will present, okay, what happens when we have humans and we use some of these resources to host humans. Barbara.
Thank you. Good morning, everybody. Yes, I work as a space architect and design researcher, and we support the main European industries currently, and also will go beyond. So currently we support TASI with the iHab and Airbus with the A-Loop. And but we also look at using in situ resources. As David explained, we know what to do with the water. I'll probably mention that to you in a minute. Next slide, please. But we are especially looking at, of course, construction technologies. So how can we build a good and safe environment for humans that is also a dust-free environment, because the dust is very harmful to machinery, to humans, to everything, living and non-living, robotic. On the surface, so we look at sintering, solar sintering, and currently are involved in a project with using a laser as a representative of a solar sinter. But the interesting thing is that we don't want to bring more material to the moon. We just want to use the sun, a concentrated sunbeam, and the sun and sand, to create either paved roads or larger structures to protect humans, envelopes, habitats. Humans in particular are very, next slide please, are very fragile creatures, so we also need to establish mini worlds, biospheres. No, go back please. Another slide back please. All right. So these so we need a lot of things. We need air. That is the most important thing, because we hardly can live without air. A couple of, like 1, 2, 3, 4 minutes, free divers might take it to 5 or 9 minutes or whatever, but then we'll die. Then we need water. A couple of days without water is okay, but not more. And then food. So these are the prerequisites. But there's also, apart from the intake, there's also sort of something, waste we need to recycle. So we need to look, and then next slide, please. We really need to look at establishing biospheres. Go back one slide again. Just a little bit too small. Too fast. Another back. Yeah, that one. So we're looking at closed-loop life support systems and how and establishing these sort of little biospheres, and also how everything we sort of have to bring for the first time to the moon, we can also use in recycle loops to make something, maybe to produce spare parts or something, for machinery which doesn't function anymore. So these are also in line with a couple of projects we did for the European Space Agency, and we are currently also looking at. And then, combining these construction technologies, but also these closed-loop biospheres. One slide, next slide. Then we can sort of come to these larger settlements on the moon. This is a lunar village. You see habitats, but you also see shelters for machinery. So it's a whole larger infrastructure. And in the back, you see a launch pad. And then we can also create larger spaces and are not so, scarce with the actual space with the sort of first outpost. And then when you imagine all these recycling and closed-loop technologies, which are so important and vital for creating a lunar or even a Martian base, these technologies, next slide please, that are also very valuable for terrestrial applications and for creating hopefully cities like moon villages or like spaceships. And when we have mastered creating a city like sort of a closed-loop spaceship, then we will also be able to create even larger infrastructures and probably generation spaceships to go further out and explore the universe.
Okay, thank you very much, Barbara. So, outposts, village, cities. Okay, so that's a quite ambitious vision. But what do we do now? What are the next steps? In particular, okay, what about Europe? So we have with us Stéphane Demey, he's Senior Strategy Officer at the European Space Agency, and he's going to describe, what is Europe doing in the next steps and possibly also in the midterm future.
Right, thank you very much, and happy to be here. We plan a lot, so I'll focus on a few points, and maybe you can start playing the first animation. We're trying an experiment. No, that's not the animation. Well, we're going back to the moon, and we're very proud we're now part of it. With our service module for Orion, we'll be part of each and every Artemis mission 1, 2, 3, 4, 5, 6 have already been contracted to industry. We're already planning for the next ones as well. And those Orion vehicles will ferry astronauts to cislunar space. I had an animation, if that would be able to play. You would see that this Orion is not only ferrying the astronauts, but also part of assembling the lunar gateway. And I'll just describe what the animation would be. There you go. So you see the SLS and Orion on top of it. And actually the gateway has several elements. And here again, Europe plays a very important role. About 50% of the pressurized compartments of the gateway are provided by Europe. And here you see Artemis 5, which will take the Esprit module to the gateway, picking it up from the SLS rocket and driving it to cislunar space to attach to the gateway. You see the solar panels rotating because it needs sunlight to do the transfer. That limits also the number of opportunities to go, and that's why the launch windows are not very often. And it goes to cislunar space, attaching Esprit to another module, also European module, the IHAB, habitation module, having a life support system, which has been matured on the International Space Station, provided by JAXA. And Barbara mentioned life support systems is a very important component, also with terrestrial applications in terms of circularity, etc. Esprit also has windows, and it may seem trivial, but this will give you a out-of-this-world view on the moon. Esprit is also providing refueling, contributing to the sustainability of the station. That's too fast. If you can now go back to the previous slide, then you see something what an astronaut from the window could see on the surface. No video, just the still image, but the previous one, please. The one with the lander. The previous. The one before. Thank you. To do things on the surface, you have to be able to go there. You need transportation. And that's Europe's next big proposal to our ministers, is to build a mid-size lunar lander that is capable of bringing payloads and infrastructure to the surface. It's meant to be capability, not a one-off mission, in support of human architecture, so human missions, but also for science and for technology demonstrations. You can have a versatile range of missions. And what you see here is a typical possible scenario in an Artemis human scenario, where, and you cannot see it on this visual, but the human lander is somewhere a bit on another side of the moon, and typically a 4-crew is landing. Two of them go into the pressurized rover and drive to a place where we position cargo that they can retrieve and start using. Multiple missions. In the back you see another lander doing some in situ resource utilization, which is here in the vicinity of a crater. But if you go to the next slide, there's another option. There is the ice, but there's also the regolith. And at ESA we also have been looking into that, and we do actively research on that to turn regolith into oxygen and metals. And what you see here is a first experiment on the left side, regolith simulant. And with salt molten electrolysis process, we have extracted nearly all the oxygen of the regolith. And the leftover is on the right side, and those are metals which could also be used further as a resource on the surface. And one advantage of this process is it's at a lower temperature than alternative processes that would require 1,600 degrees. So it has really quite some potential. It's also a carbon-free process, so it also has some possible applications in terrestrial metallurgy with CO2, with carbon-less process techniques. Right. Next slide. Well, the next slide was again an animation. Right. actually, what you saw now is what we envisage in the coming years and well into the 2030s. It's a very modest step in a human settlement on the moon. We start very simple, not simple, but modest. But we also envision, on the long term, more permanent human presence on the moon, a permanent research station maybe, and then later on we have already seen some images of more extensive settlements. Now that will take time. That's not in our strategic planning for the near term, but we're thinking about it, and we actively do some thinking and work, and this is what you see now, a video from SOM. It's an architecture company known for large skyscrapers, but they did some work with us and designed a 4-story high semi-inflatable habitat for the moon, and a vision on how that can grow a permanent settlement on the lunar surface. This is inspirational. It's not in our planning, but it makes us thinking. And one of the things which is very important, and that's not only ESA, actually with the International Space Exploration Coordination Group, 27 agencies, we have a science working group, and there are many topics, but 2 important aspects is science for sustainable exploration. We need the knowledge, we need the ground truthing, not only the remote sensing, to be able to do the things we want to do, and we need responsible exploration. And the 2 go, it's not the same, but they go hand in hand. And this responsible exploration is necessary to preserve the lunar exosphere, to avoid contamination, to avoid we do irrevocable things by doing what we're doing. And with this, I think I end my intervention, and you can stop the animation.
Thank you, Stefan, for this presentation, and Isa for considering also this aspect of protecting responsibly our 8 continents, step by step, that we are going to explore. But for that, we have also to establish or follow a set of regulations. So what is the legal status of the moon and its protection? So we have with us Tanja Masson-Svan, professor of space law in Leiden University, also a long-term friend of IF and also IISL. Tanja.
Thank you, Bernard. Can we stop the animation and start the slides again? Yes.
You are. Okay.
And this is, no, you have, okay, that was, next one. Thank you. So thank you, Bernard, Michel, for organizing these sessions, and happy to be here to also inject some legal considerations into these exciting plans that are being developed, and that is, of course, important. We've heard several times that sustainability, responsibility in all these plans is going to be necessary. It's all very exciting what we can do, but let's make sure that it doesn't become a race to the bottom. So we have a number of principles of international legal treaties that have been adopted since the start of the space age by the United Nations, and they lie down a number of rules that states have to follow in the peaceful use and exploration of outer space. So the fundamental treaty is the Outer Space Treaty of 1967, which has more than 110 member states, so really all the spacefaring nations are a party to that. And they lay down these principles, but they do not really say a lot about protecting the environment. They are not, there's no obligation to not create debris or to remove defunct satellites from orbits and things like that. And we're starting to talk now a lot about sustainability, but the only real point of attachment, if you like, in that treaty is its Article 9, which says that we should avoid harmful contamination of celestial bodies, which is the moon and all other celestial bodies, without there being actually a definition of what a celestial body is. So technically the moon has the same legal status as a piece of rock, asteroid, or whatever, so far. But there is not also really a prohibition to create such harmful contamination or interference with the activities of other states. The only thing is that if there is a risk of such harmful contamination or harmful interference with the activities of others, there is a duty to consult, to enter into international consultations with each other. Yesterday we had a whole session on this topic as well, and I raised the question, is anyone aware that such consultations have ever been initiated? And actually nobody came up with an example. So it may be time when we have currently also interference of satellite mega constellations with astronomy. Perhaps the time will come that this article will actually be implemented. But so far, as I said, not a binding duty to avoid contamination. The Moon Agreement of 1979 has only 18 member states, but does go a little bit further. It confirms the principles that are in the Outer Space Treaty. It also says that we could assign certain regions on the Moon and other celestial bodies as areas of specific scientific interest. And so this would be, of course, interesting for what you mentioned, like the far side and the permanently shadowed regions and so on. If we go to the next slide, besides this series of treaties that we have, which is binding law, we also have emerging what we call soft law. And soft law is not legally binding on states, but it can become customary international law if there is sufficient state practice and conviction that something has to be a certain way. And that means that if that is happening, that it is just as binding as a treaty. Also, these non-binding principles can be transposed into national law. And we see that, for instance, with the space debris mitigation guidelines, which are often made mandatory under national legal regimes. Private actors, which are going to be quite crucial in this next stage of humans' endeavors in space, will be bound by national law. States have to authorize and supervise their activities. So that's why these soft law principles, and I've put 3 sets there, are definitely not anodyne. They are important. COSPAR, planetary protection principles, Bernard has mentioned that these have been followed for more than 50 years by all the responsible space agencies, but we'll have to find a way to also have private actors implement them, right? So at the national level, we'll have to make sure that they also follow them. The space debris mitigation guidelines, I mentioned those, but the problem is that they only apply to orbital debris. They do not apply to debris on the Moon or other celestial bodies. We have no rules that apply to that. The long-term sustainability guidelines, which is the latest achievement of UN COPUOS, adopted in 2019, a very extensive set of sustainability guidelines. Again, they do not seem to mention lunar pollution or contamination as one of the areas of protection. So we have also a number of non-governmental initiatives, and we've heard about the prospect of exploiting resources. Surely that will happen. I've been involved deeply with the Hague Working Group that adopted a set of building blocks, which are now being considered by UN COPUOS, the UN Committee on the Peaceful Uses of Outer Space, to set up a governing system to govern the use of space resources so that it doesn't become the Wild West, as we all say. For All Moonkind is also an interesting non-governmental initiative which wants to protect the heritage in outer space. And of course, as I said, the Moon Agreement has that provision about scientific preserves, but we also have cultural heritage. And of course, for many peoples and indigenous peoples, the Moon is a very special place. So it is important that we create awareness about that. Open Lunar Foundation, again, is also an organization that I'm involved with, which tries to also raise awareness and create transparency. They have, for instance, a project to create a moon registry, where we can register what is there and what are the plans and so on. So all these non-governmental initiatives can also help build that consensus and that conviction that we need to preserve outer space. I think I have one more slide where I say, what should we do? So we do not have binding law, we do have some soft law. It is difficult at the moment to reach consensus, to get everyone on the same line in COPUOS with increased membership, increased stakeholders with all their own objectives and priorities. We have an increase of missions. And of course, eventually we will have permanent settlement. So we have to find ways to implement these principles, and I would advocate for continued support of UN as an important forum, which is the only place as a unique platform where all states come together and to try to preserve outer space for future human exploration. Leave it.
Okay, thank you, Tanya. So we have heard the context from the history, from what the various agencies are doing. So at least we have heard NASA and ESA, the COSPA aspect, UN you mentioned. And soon we are going to ask the industry to tell us their point of view. But I think it's a good moment to ask the IAF citizens to give their point of view. So if you have any question, please come and grab a microphone and ask your question. In the meantime, maybe I'm going to start the first one, because with Tanya, you mentioned Outer Space Treaty. Also, this tells you that we should not militarize the moon, so space in general, and the moon, no weapon of mass destruction. So we are not going to bomb the moon, for instance, to accelerate exploiting resources. So how safe, how secure is it that we will stay this way? And then other question.
The treaty actually doesn't prohibit militarization, and I think military use of outer space is a given. Space is used for military purposes.
But for the moon, celestial bodies?
The moon has you mentioned weapons of mass destruction, nuclear weapons, that's prohibited everywhere.
Yeah.
And it's true that for the moon there is a more strict regulation that says the moon has to be used for exclusively peaceful purposes. So you cannot put military installations, test weapons, and so on. So indeed there is a stricter regime for the moon and other celestial bodies. And obviously with the current geopolitical climate, increasing tensions, space forces, and you name it, this is becoming more and more difficult. But on the other hand, we are also interdependent. That I'm maybe an optimist, but I have some hope that we are able to maintain that principle of international law. That applies to all the parties of the treaties, of course.
I understand this was in fact also guided by the threat that somebody could put on the far side of the moon a nuclear weapon that it would send to the Earth, and you would not have time to detect it. And so this may have accelerated the fact that all the countries approved the Outer Space Treaty. So we have to be really careful. Any other questions? Yes, please. Identify yourself and address your question.
Hello, this is Anand here. We are developing lunar rovers. I'm from India as well. So while looking at the exhibition below, I saw Rolls-Royce is building a nuclear reactor for the moon. So how does that obey the treaty, that moon treaty that is being built?
So that is nuclear power for electricity, but that's not what we would call a nuclear weapon. Of course, it's what is a weapon. There is no internationally agreed weapon, but nuclear power is in principle not prohibited. There are, however, United Nations guidelines to do that safely. And so that is not prohibited.
Okay, so eventually when I asked them, they said the lifespan of the project that they are building is for 10 years. So after 10 years, that would be left on the moon. So is that...
yeah, then you have garbage on the moon. So that is what
there is nuclear garbage on the moon. So
okay, so a legal question. But let's see agencies, how do they deal with that? Because clearly nuclear energy could be green, in fact. So allows you to survive, in particular this 2 weeks night that we have in the non-polar regions. So of course you have to take care of it very safely. So how do you handle nuclear energy activities on the moon? Yeah?
I feel I have to contribute because despite the fact that I work in Thales Space for exploration, I have a nuclear engineering background. And so when I studied, nuclear was forbidden in Italy. But I think that we need to open our eyes and realize that either we change completely our society, including also exploration in space, or we need to develop new ways to generate the power we need. So as for lunar exploration, I am involved with different universities that are working at designing a small, as NASA did with the kilopower. So a small contained nuclear plant, because if we want, and we will need to dig and process and transform the local regolith into resources. You know, if you don't work them, they are materials.
True. Yes.
If you want them to become resources, you need to play with them, to separate, not to extract, to separate. And so photovoltaic power on the moon is tricky, because if you have your base near the equator, then you have, you know, this cycle, 14 days and 14 days of daylight and night. Yeah. And so you might decide to stay with photovoltaic, but then you will need huge amount of batteries, and that is pollution too. So as an engineer, I
that
think
is what we are facing. So we are facing whether to take lithium ion as in junk or the this. Sorry.
Yeah. Well, we shall do better than what we did on our planet, on our satellite, that for sure. I don't want
Excellent.
to be
So
too long.
energy is a key issue.
Energy is a key.
Resources on the moon. I have a question for the audience. What is for you the most important resource on the moon? What?
Helium-3.
Helium-3, that's for energy. So in 50 years, we'll get helium-3, we'll get a
Yeah,
clean.
but to extract helium-3, you will transform the moon morphology.
But you know, it's a 1 part per million, so you need to process
you will
it.
transform the moon.
Any other resource? Water, great. Water ice. And I have estimated you can have a 1 billion ton of water accessible in this permanent shadowed area. Okay, let's say we are not going to use it. We should use only 1 part per 1,000 to help bootstrap our life support system in bases, and also for this cislunar economy where you can launch rocket from the moon for 50 times less energy than from Earth. What is even better than water? Something which has value and no weight.
For value, no weight.
No weight. Photons, information from the moon. You said.
Voilà, this is your scientific
And what else?
soul that is coming out,
Scientific,
Bernard.
but even better than that, creativity. You can harvest the creativity. Let's find a creative solution that all of you can implement. And those creative solutions we can also use on Earth. Like for instance, we are looking at smart solutions for solving this energy problem. Creative solution working together. So, okay, so this is a parenthesis. Let's involve any other one other question for yes, please. So we have a Verle Sterken, so that she's recognized the planetary dust scientist.
Yes, So I have a question about dust, obviously. So has ESA or any agency been thinking about how the dust cloud is going to change around the moon? Because we do have a dust cloud up to 100, 200, 300 kilometers. It has been measured. Should we monitor how it will change?
So there was a mission called LADDI, the Lunar Atmospheric Dust Exploration Observer, also run out of NASA Ames, and we found over a period of about 6 months where we were orbiting the moon that there is indeed an exosphere. It's not exactly like we thought. We thought it was actually a little bit more challenging because the astronauts had seen on sunrise on the moon, basically a cloud of electrostatically charged dust. And so the fear was that as the Terminator would cross on the moon, there would be this cloud of dust that would kind of get charged up, rise up very high, and sweep across the surface of the moon and cause problems. We found that that problem did not exist. But it's also a very interesting pristine environment because as you disturb the dust does not settle simply over time. And actually there's a transport mechanism for the water. So as you release, which the Apollo astronauts did, their atmosphere, every time they opened the door, stuff would come out. It would need to transport. It doesn't just escape into space. The moon's gravity is significant enough that it will settle over time, and it will settle into the craters. So that's how they think the water actually accumulated in the permanently shadowed craters over billions of years. But the atmosphere, the exosphere of the moon, is not well understood. We've only had one mission to discover what is the current status of it, and the moment we get there, it will go from pristine to disturbed. So we need to be considerate of, like Bernard responded, data, science. It tells us the moon is literally this cold box right outside the edge of the Earth that tells us about the fundamental state of the solar system that we cannot otherwise easily discover. And so we have a choice. We can go out there and play in it like it's a sandbox, or we can treat it like it's a fragile tomb and crypt of information and mine the data first. We just need to figure out when and how to do competing priorities in a responsible way.
Mm-hmm. Yeah, excellent. So, yeah, the moon as a history book to understand better, processes that form planet. Also, as a place where we have very specific environment, this deposit of ice, they could also include hundreds of comets or asteroids from the past. So you want to preserve this region, not contaminate, and do not drink the water ice from the moon, because there are cyanidric contents, so we have to clean it first. But other question is, the dust is your enemy for spacesuit, but it's your friend if you can harvest the regolith properties. So one room for a last question before we challenge the industry to see how they address all this. Anybody has
Bernard,
yes?
just a small comment on
Yes,
that.
please.
With regard to what was said before by David, I think that also we have to understand exactly the level of activity we will have on it. If it's a very low level as it is until now, we have been only 6 times on the moon until now. So it's very low level. But if we plan to have more travel, more people on the moon, permanently working on the moon, we have to see the evolution of the atmosphere, what it will be.
But for instance, from Apollo, every time that we had a rocket stage descending, it took a few weeks for the exosphere to go to equilibrium. And I think here we are looking at scenarios where we would have more than that with all the partners. So Antonin has a question. Yes?
Yes, thank you. I'm a student at Superhero. I have a question because we've seen that on Earth we have some problems to deal with exponential growth in a finite world where we have finite resources, and we all agree here that Moon is a really fragile environment we all want to protect. So how do you think we can do better in this new world, sustaining that growth that we cannot repel ourselves to perform, and how do we protect that environment, and further out how we will do for Mars exploration, how to deal in terms of planetary protection and resource preservation with this exponential growth we are performing everywhere.
Okay, we want to address how to set example from the technical and the responsible side. Barbara.
Just a quick answer. I think, yes, we will do better because we will have no other chance. The only way of humans surviving in these extreme environments is that we create these biospheres, and we need to, and we can't afford putting constantly supplying goods to the moon. So yes,
and
that
even
is the
further,
good thing.
yeah,
That's
and
the
even
good
further,
challenge here.
this solution that we implement for the moon, we are going to bring them back to Earth. For desert, for life support systems. We have water management system now in cities that are inspired from what we do with the Melissa project. So we have also to feed back down to Earth and be responsible, show example, and apply that to Earth and get it through. So thanks, Antonin. And now you see the industry as an easy task. You have all these requirements from society, from science, from legal. How do you address that? And so I would like to ask our first representative, Wolfgang Duer, from Airbus Defence Space, Head of Marketing and Sales for Space Exploration. Wolfgang.
Bernard, many thanks for inviting us, also the industry, to this distinguished panel. Thanks, Michel, for the great organization of the panel. I think we address the right questions here already. I appreciate very much the discussion already ongoing on that. And it underlines clearly the responsibility of all of us, especially the OEMs, the prime contractors, and 3 are here represented on this panel, what we have when further exploring the moon, building up this ecosystem. and make it as sustainable as possible for our future generation. That they also have it habitable, and that they have the opportunity and the possibility to also explore, exploit, and utilize the moon resources also in future. So maybe you can go to the first slide. This just shows pictures we all saw already, some artifacts, how a moon economy could look like. This is an ESA picture. And it's a lot of these capabilities, technologies have been already mentioned, which are important. And I would like to mention maybe one where we are closely involved with ESA. It is the ROXY process, where we extract oxygen from moon dust and then have the metal powder available, which could then be taken for construction with 3D printers for structures over there, also maybe building up habitats in future. So this is one of the technologies. And you mentioned a very important point is maybe the non-materialized effect and benefit of the moon exploration is also the innovation, which we create with all these capabilities we have to build up for the moon economy, for the ecosystem, and which also help us on Earth to maybe get a better life and have the spin-offs available from space on the Earth. What has to be considered, a lot of these topics have been already addressed. I would like to address it in 3 building blocks. The first is the transportation logistics. Everything what cannot be produced maybe in future on the moon has to be taken up to the moon. This needs a lot of transportation, maybe a lot of additional debris, pollution also, we have to think about that. So everything what we can do on the moon, oxygen extraction, water is important, helium for future, also power generation on the moon. So we should do on the moon and not bring everything from Earth to the moon. This is important. And important project is also for Europe, the landing logistics, the EL3, European Large Logistics Lander, which we hope that we can get it subscribed by the member states in the upcoming ministerial conference, that we really can step on our phase 0A studies, which we successfully completed and now hopefully can build the lander to have it available by the end of the decade. And not just for Europe, but also for NASA and for other users on the moon. The same is for orbital logistics, interorbital logistics. So we have to also keep an eye on that, what we have to transport interorbital, and that we have the right solutions, also a kind of independency for the European side, but also it is an international collaboration. This is important, and we have to really be efficient as possible when it comes to the resources utilization. The orbital infrastructure has been addressed with the Lunar Gateway. This is very important, that we have this pre-step more or less for our astronauts before they go down directly to the moon and back. This is the first building block. The second is more or less the enabling services and technologies around it. When you want to build up habitation, when you want to have surface mobility on the moon, you have to have communications, you have to have navigation, so this is an important part. ESA, again, addresses this with the Moonlight project, which is also part of the ministerial this year. So everybody who wants to live on the moon and want to move on the moon should have some communication available, and this is also something what we have to think about, just as an example for that. And then you have the big block of enabling technologies to live, to work, to do what you want to do or what you have to do on the moon surface with the energy and the power plant, the surface mobility, the infrastructure over there. And it's amazing to see how many stakeholders, how many companies, a lot of startups working on these topics nowadays. And this will also underline an important topic which I put here under the term of waste management over there, because currently we heard about that a lot of exploration still has to be done on the moon, but the problem, or the fact is, maybe not a problem, it could become a problem, is that commercialization is moving fast. And since space became more affordable over the last years. We have a lot of startups, a lot of commercial companies want to be on the moon surface within or by the end of this decade. And we have really to think about how we standardize, how we assure interoperability, not to duplicate everything, to work together. And this is a very big challenge, I think, for us and to complement each other. And this is what I mentioned in the last slide. What we came up last year at the AIC in Dubai, it was an initiative of Airbus, Air Liquide, and iSpace. We came up with this Euro to Moon. We named it Euro to Moon, but it's not just for Euro, it's also for other interested stakeholders in the world to really go after this, after the standardization. See how space companies, non-space companies should work together. This is a non-profit industrial association which really has the objective to support the definition of standards for coordinated approach between all the space actors involved. And you are all invited to join this Euro to Moon undertaking. And if you have some time, tomorrow we have a reception at our booth or at the Luxembourg Space Agency booth, since the association is registered under Luxembourg law. And there we can probably have a discussion how we approach this and how we want to create a future, also with Euro to Moon.
Thank you. So with Europe to the moon, because of course it's open to the whole world. Huh? So come to the reception. So we have seen a number of activities going on to prepare from the European side. And what about the United States? How smart do we have to be? So Eric Smith, Director of Artificial Intelligence and Data Analysis in Lockheed Martin.
Thank you. It's amazing to be on this panel with these experts. Really fascinating topic. If we can go to the next chart, please. So, on the question of what are prime contractors going to do to solve these problems, I'll say prime contractors do not have all the answers. I mean, we rely on these amazing ideas like centering the regolith with solar energy to create habitats. I think that's a fascinating idea. That's just wonderful. So Lockheed Martin really is very proud to be one of the companies that's forging a path back to the moon. We're, of course, building Orion, which is going to see the return of humans on the surface of the moon just in, I mean, it's right around the corner, just a few years from now. I mean, Artemis 3, a few years from now, we'll have humans back on the surface of the moon. And the CLIPS missions are bringing autonomy and robots to the surface of the moon within a year. So, I mean, it's happening right now. You know, we partnered with GM and MDA Canada to bring fully autonomous electric rovers with robotic arms to the surface of the moon for commercial use. And, you know, the range of this, I can't say what it is today, but you can kind of extrapolate the range of electric vehicles on the surface of the Earth without the atmosphere in the way. These are going to go quite far. There's a lot of opportunity to be exposed to and expose a lot of the surface of that regolith in that process of commercial exploration. We're building the Parsec system that provides continuous communications and navigation from the surface of the Earth to the lunar surface and all points in between. We're one of the companies that's coming up with the concept for these fusion surface power units. Fairly modest, 40 kilowatt units that have a 10-year lifespan, as the gentleman mentioned earlier. And we're also working with NASA to build designs for vertical solar arrays. So taking advantage of all the various sources of power that we can. But we're also a member of the Moon Village Association's global experts on sustainable lunar activity. So we're not just about go fast, explore, break the boundaries. We want to preserve and protect. There is a balance, as was discussed before. There's a balance between exploration, scientific discovery, commercial interests, and preservation. Lockheed Martin is a global company. We're multinational, and we adhere to the laws and the cultural norms of all of the countries in which we operate. And so for us, part of the question is regulatory stability. Where regulatory instability exists, we find a lot of roadblocks to progress. So that's one area that we need stability in order to really build the future that we're showing, for instance, on this chart. And the challenges are data. David's example was fantastic. We knew nothing about this exospheric dust cloud until we studied it a little more. Now we know something about it, but we know something about that dust cloud that might have appeared from some amount of prior activity, meteorological activity, human activity. And so it's about metering our activity as we arrive on the moon, gathering data, and learning from that data. And I'll say it's not just about taking into consideration the spacefaring nations. The entire world has a stake in what happens on the moon. We had that little discussion about technological advances and lessons learned on the moon benefiting those on Earth. That has benefit everywhere. So, thank you.
Okay, so thank you, Eric. So yes, perspective, going at the right pace, respecting what is there, but also engaging, being inclusive of other countries or other activities. So in this balance between space economy,
zero time.
We still have 7 minutes.
Okay, then I
So,
thought that was over.
Space economy.
No, space economy. I like to speak about people.
People.
Yeah,
Excellent.
because I told you I will complement what the other panelists said. So first of all, as Eric said, this story is really happening in Thales Alenia Space. We are welding, not designing, welding the pressurized modules for the gateway, and we are preparing the next module for the surface infrastructure. So it's really our daily life. I wanted to use this chart because, as my colleague said, there are different building blocks that will be needed to really to initiate this little outpost on the lunar surface. So I won't bore you with all the building blocks, but let me complement the discussion by focusing on human needs. So we will have all these robotics tools that will prepare the path. But then when we design a module to host very few people, because this is a fact, at the beginning will be 2 people, maybe a few years after 4 people. So we are designing these environments in a different way with respect to what we did for the International Space Station, because for sure we have to provide, how can I say, an internal architecture that is really human-oriented. These people will feel far away from their families, their kids, and so the human aspect is super important when we develop possible solutions, and also the psychological aspect will play an important role. We work a lot with Barbara for the internal design, but not only the internal design. So not only a human-centered environment, but also we need to provide a safe environment. So, on the moon, we find a very hostile environment. So all the radiation are impacting us. The thermal environment is super tricky. So we work a lot with water. We hire water for drinking, for propelling spacecraft, but water also to protect from radiation. Water is really important, is an important resource. And talking about resources, another important building block, really to help closing the loop, not totally closing the loop, is the greenhouse. In all these beautiful representation, we see the greenhouse. Well, I'm glad to share with you that we are working a lot also in this direction. We developed an interesting experiment, Eden, that was brought to the to our South Pole, to our planet South Pole, 2 years ago, that produce a lot of vegetables, mainly salad. Am I saying that people will not need the food from Earth? No. This is that just to complement the food that for sure will be carried from our planet to the moon. But a greenhouse, beside providing salad, might help closing the life support system. So I could. And psychological aspect, because people will have to care for something lived, for a form of life.
Okay, thank you. So before we end, let's give the floor to our representative from our host, CNES, so Jean Blouvac, so Program Manager for Human Spaceflight and Exploration Activities at CNES.
Thank you very much, Bernard. Thank you to be all here. It's very interesting. Very honored also to be within this panel. I think the conclusion is very simple. We have plenty of work in front of us. On one side, we will go to the moon now, not just a simple travel. It will be maybe permanent. It will be on long term. The activity will increase on that kind of thing, and I think the move will not stop. It's a kind of new move. But at the same time, we have to preserve this fragile environment, and it was said, for scientific reason. Here also we have plenty of things to discover. We don't know, in fact, much of it. It's only a little part we know. So we need absolutely to preserve that. In the discussion, there was not much on the science itself, but there are some ideas we discussed quickly on maybe astronomy with regard to the electrical spectrum that we should preserve. We discussed about the regolith and what will be in the atmosphere, the water itself. So science, how to exactly preserve that. On the other side, of course, the activity itself will be a development maybe for economy, for new ideas, for new innovation. And this is also a kind of important thing which is necessary for our evolution. And so on the long term, if we want to keep it, we should, of course, do it as clean as possible. Otherwise, by itself, it will decrease, and it will not permit to have all the objectives we have with regard to that and with that kind of economy. And also, it might not provide what will be the feedback for Earth, because all the innovation we will do might be of interest for sustainable life on Earth. So, with regard to that, of course, the question is how to do that. And here is a real question. So we heard about what might happen on the regulation, on the legal aspect, which are maybe not enough binding on that, which might be behind that checked on the way it is really done, which is a real problem. And for industry also, we saw that it should be stable, it should be clear in the future for developing new activities. Otherwise, there might be oscillations, there might be things like that, or there may be a kind of challenge that might happen, and generally it's not very good. And I think also that for that, within that framework that we should build as quickly as possible, we have in all our projects to take care and to define kind of specification or guidelines we will apply, and maybe even more on the long term. We have seen with the discussion or the question that happened with regard to the nuclear power, that there is an end-of-life question. What happened with that? And should we bring it back to Earth or not? This is a question, an open question. Until now, as an engineer, it's very difficult to go to the moon and to do the travel, but maybe in the future we should be careful of the waste and of that kind of thing.
Okay.
So I think this is all the things that were brought today, and it's in front of us.
Thank you. Thank you, Jean. Thank you to our panelists. We have also to deliver on time. So we have a campfire we have to sustain. And I think this is going to continue with you and trying to think about, how we approach responsibly lunar exploration, utilization, also as a model of what we are going to go to do in space and on Earth. So I want really to thank the organizer of this meeting, Michel Blanc, the panelists. A big round of applause for the panelists. Now, the campfire is going to propagate. So now up, you take the torch and you are going to bring that to your session. There are a number of solar system sessions. Today we have a Mars session. We have also human space flight. I want also to say that we have various organizations. Space Renaissance, for instance, has a booth with Your Moon Mars where we are going to drink not moon water, but to celebrate ISC. And also we are going to celebrate a special event. We have a book that has been edited by Professor Michel Blanc about Horizon 2061, which is and a number of our colleagues, which is just appearing this month. So we have a special moon drinks and solar system drinks. So every day at the Space Renaissance booth, D11B at 5:45, music included. You are all invited. But also, okay, did you like the format of the campfire? Maybe we did a bit more time, but we will continue in the various sessions. So thanks everybody, and we give the room to the next. Stefano. Okay.
Thank you all. Thank you to the wonderful panelists.